Guys, we are looking at our last unit on probability. So in our note packet, our first page is about probability and the guided notes. Probability is the likelihood of an event happening. Okay? And all probabilities range from 0, no chance, to 1, absolutely certain. Okay? And probabilities can be expressed as a fraction, a decimal, or a percentage. Okay. So looking at a probability line, if there is 0 chance, then we would have 0 probability. If we were absolutely certain it would happen, it would have a 1 chance or 100% probability. But this is kind of like never and always. And never and always, well, they can get a little difficult, right? Because usually it's kind of a maybe, it depends kind of thing where the probability is somewhere in the middle between not going to happen or absolutely will happen. It's going to fall somewhere in between those two. But where we have the probability of it being half, so half on the not likely side and half on the likely side, we call that an even chance. And it's very much like flipping a coin. One has to happen, okay? And so let's say it's getting the coin to land on a head, okay? Well, the 0 to 1/2 is head, and the 1/2 to 1 is tails. One of these two has to happen, okay? And we call that an even chance. So let's look at some both personal examples and mathematical examples. Okay. So each of the events described below can be described as impossible, unlikely, they have an even chance, likely, or certain. Okay. And then number 1, Thomas Jefferson, the 3rd president of the United States, will visit the college of William and Mary tomorrow. Impossible. The dude is dead, right? He's not going anywhere. Not today, not tomorrow, not next week. Impossible. Now, you may ride the bus home from school today. In that case, you will choose likely, possibly certain, or if you walk home from school, you might choose impossible or unlikely. If you're not sure if you're riding the bus or if your parent is picking you up, you might go with even chance between riding the bus and getting a ride home. Okay, that's a personal to you choice or likelihood decision to make. Number 3 asks us, how likely is it that school will be canceled tomorrow due to bad weather? Well, if it's, hurricane season, that might be an even chance. Maybe, maybe not. Don't know. But frankly, as close to the end of the school as we are, I'm going to go somewhere between impossible and unlikely. And I'll probably settle on unlikely, unless, of course, a tornado tears through the school and it's closed because, well, it's damaged. Okay? But otherwise, in general, I'm going to go with unlikely. Number 4 says if you roll a standard die, a 6-sided number cube, that it will show a number less than 7. Well, on a standard number cube, you only have numbers 1 through 6. They are all less than 7. You will certainly roll a number less than 7 on any one 6-sided number cube. Right? We saw this in our activity, where if you flip a coin, it can come up heads, it can come up tails, but there's an even chance of either one, okay? Heads is just as likely to pop up as tails. Okay? And that's that idea of fair, where all outcomes have the same likelihood. And we see that very nicely in coin tosses. So turning the page. Okay. All right, so probability is a ratio. Now, this is some math grammar. When we see a capital P on the outside of an open parenthesis set, and we're dealing with probability, this reads, probability of this event is something, okay? So when we're dealing with probability, these parentheses are not multiplication. So I might put something like P open parentheses rain equals 50%. The probability of rain is 50%. I'm going to go ahead and write that down. Okay, I wrote it down. I hit pause so that you wouldn't have to just watch me write that stuff. Okay. So another thing we need to know when we're dealing with probability is a favorable outcome. Now, I don't like the word favorable because that means good for me. That might mean bad for you. So is it really favorable if it's good for me and bad for you? I'm going to change this, and we are going to call it a yes event. That yes, the event did indeed happen, and that is the outcome that the yes event happened. Okay? So in order to find the theoretical probability, we divide the number of yes events by the total number of possible outcomes or possible events. This will become clear here in just a second. So if you flip a coin, there are only two possible outcomes. It can land on heads, or it can land on tails. That's it. You got two. So the probability of the coin landing on tails, option the yes event, I have one way for that to happen, but there are two outcomes, heads or tails. So let me write that down. Got one yes event and two possible events. Okay. And that should be an equal sign in there, because they are the same thing. One yes event out of two possible events that could happen. So in the next one, what is the probability of the coin not landing on tails? Okay, so anything other than tails is not tails. And in a coin toss, all I've got is the two. So it's the probability of the coin landing on heads. Okay, well, in order for it to land on heads, the yes event only could happen one time, but I still have two possible events, heads or tails. So this is that even chance that we see in coin tosses, all right? Now, this complement word means the event that is not happening. You guys tend to get this word not confused. All right, so let's be real careful with the way we use the word not. But the definition of a complement in math is not the yes event. I know, it's weird. But you could call it the not favorable, or what I'm going to call the no event. Okay, so we have event that happened, and we have everything else, or the no event. Okay, And this is written as P on the outside of event A with a bar across the top. I don't like that, so I don't use it. Mostly because my handwriting is so bad that I don't always see the bar. So I will use P not A, okay? So the probability of not yes event. Okay? So I need the probability of a yes event and the probability of the no event to equal 1, okay? Why? Because it either happens or it doesn't. This is certain that it either happens or it doesn't, all right? I know it's a strange concept, but it'll become a little more clear as we work some problems. Now then, I'm going to do a little bit of algebra, and I'm going to solve for the probability of the no event, which means this yes event is on the wrong side of that equal sign. I'm going to subtract it from both sides. So the probability of the no event happening is certainty minus the yes event. Sorry. So let's take a real quick look at this bag of marbles. Okay. What are the possible outcomes? Well, there are 10 of them. I've got 10 marbles. All right, I've got 3 striped. So I could pull a stripe. Striped. All right. Okay. Striped marble. I could pull a white marble. I could pull a black marble. There are 10 possible outcomes because I have 10 marbles. I'm going to write that over to the side. Okay. So what is the probability of pulling out? I'm going to reach in this bag with my eyes closed, and I'm going to pull out a striped marble. Well, there are 3 yes events, but there are a total of 10 possible events. So I'm going to take that fraction and I am going to convert it to a decimal. And I'm going to turn that into a percentage. So I have a 30% chance of pulling a striped marble. For the black marble, I have 1 yes event, but I still have 10 possible outcomes. Again, I'm going to turn that into a decimal and turn that into a percentage. If you don't know how to convert fractions to decimals to percentages, Monday after school, I will be happy to show you how this works. Oh, here's that word, not a white marble. Not a white marble. Well, there are 1, 2, 3, 4, 5, 6 white marbles. So I'm going to write that down. So 6 white marbles. And everything else is not white. Okay, there are 1, 2, 3, 4 of those. But I still have 10 outcomes. So again, my yes event plus my no event has got to equal the total number of events, okay? Because 4 plus 6 equals 10. And once again, I'm going to turn that into a decimal and a percentage. Now, how about a polka dot marble? I could empty this bag and not find one because there are no polka dot marbles in any of these 10 options that are in this bag. So there is a 0 chance of pulling a polka dotted marble out of a bag when the polka dotted marble doesn't exist. Okay? So that's kind of how we're going to start off with probability as far as coin tosses and pulling things out of the bag at random. It'll get more complicated, I promise, but for today, that's where I wanted to show you on this. All right, our next piece is the geometric properties, okay, or probabilities. And this has to do with if I've got a whole space, what's the likelihood of me getting into a smaller space, okay? And the first half of this page, guys, is a refresher on how to find area. But we just did that unit. If you don't know, Mondays after school. Happy to go over it with you. So instead, I'm going to go to the second part of the page. And I am asked to find the probability of landing on the shaded area. Okay? Well, what does the whole field look like? The area of a square, 12 meters times 12 meters is 144 meters squared. Okay? That is the entire area that I could land in. But I want to know what's the likelihood of falling into this part of the circle. Well, I'm going to find the area of that circle. The diameter is 12. That means my radius is 6 meters. Okay. So pi radius squared is going to give me 36 pi. But 144 meters squared and 36 pi, these are not like terms. So I am going to have to do a little math and multiply out pi in order to get a number that can interact with this area of the square. So when I did 36 times pi, I got 113.1 meters squared. And the process hasn't changed. The yes event, jumping into the area, divided by the total possibility, the entire area of the square, 113.1 divided by 144. So 113.1 divided by 144. When I put that into my calculator, I got 87.5%. As a decimal, I got, 78.5. And so when I turned that into a percentage, I got 78.5. This circle represents 78.5 of the available area of that square. Okay. All right. The next one, process still hasn't changed. Okay. The entire possibility is the area of this large circle, but I want to get into that shaded part. What is the probability that I'm going to be able to do that? Or what percentage of the whole circle does this shaded part encompass? Well, let's figure that out. The area of the large circle, again, is pi r squared. The radius of my large circle is 8. So I am going to take 64 pi. And then the area of the small circle with the radius of 3, pi r squared, gives me 9 pi. Okay. But pi and probability, I'm going to turn these guys into real numbers. Okay. So I'm going to take 9 times pi and get 28.27 meters squared. And 64 times pi is 201.1 meters squared. I'm going to set my yes event, the area of the small circle, over or divided by the area of the whole option. And when I put that into my calculator, I get 14.1%. Or I get a decimal 141. Okay. In the next one, remember, this is a semicircle, okay? So probability of landing in the semicircle, this is half a circle. So when I do the area, I'm going to do pi r squared divided by 2 because it's only half the circle. The diameter of this circle is 10, which makes the radius 5 meters. Okay. The square has a side of 10. It's a square, so the other side is 10. The area of the square is 10 times 10, or 100 meters squared. All right. Radius of 5. 5 times 5 is 25. 25 pi divided by 2. I'm going to do 25 times 3.1415 and take that answer and divide it by 2, and I get 39.27 meters squared. So the probability of landing in that semicircle is my yes event, the area of the semicircle, divided by the entirety of the options. So 100 meters squared. So my probability, when I put that in my calculator, is 0.393. And if I turn that back into a percentage, it is 39.3%. Okay. The 3 I came from rounding, the 7 bumps the 2. All right, number 4, the one with all of the circles. Okay. If edge to edge, that diameter is 4 feet, then edge to edge for that circle is also 4 feet. I have 4, 8, 12 feet as the length of that rectangle and 4 feet as the height. So 12 times 4 is 48 square feet. And the area of one circle from the center to the edge is half the diameter. So 2 feet is going to be my radius. So pi r squared, 2 times 2 is 4 times pi, 4 pi. And when I put that into my calculator, the area of one circle is 12.57 feet squared. But I've got 3 of them. So I'm going to multiply that number by 3 and get 37.7 square feet. So if the circles take up 37.7 square feet, and I only had a total of 48 square feet to work from, then this probability should be pretty high. But the process hasn't changed. I'm going to take my yes event, landing in one of those circles, divided by the entire space, 48 feet squared. And when I put that into my calculator, I get 0.785, or 78.5%. I've got a pretty good chance of landing in one of these circles. Let me know if you have any questions.